Kepler telescope was built for one purpose: to look at a certain patch in the Milky Way in search of exoplanets. The exoplanet hunter observed over hundreds of thousands of stars and discovered thousands of exoplanets during its lifetime.
Liftoff of the Delta II rocket with
Launched in 2009 as part of NASA's Discovery program, Kepler's job was to constantly scan a fixed patch of sky within our Milky Way galaxy to find planetary systems. At the time of the launch, it had the largest primary mirror ever sent into space, and it also had a 96-megapixel camera to process the light. Astronomers were interested in finding out just how many stars have planets orbiting around them, and how many of these extrasolar planets or exoplanets have conditions that are suitable for life to develop. In its 9 years in space, Kepler observed 530,536 stars and confirmed the existence of 2,662 new exoplanets. These exoplanets are unlike anything we've ever seen in our solar system before. Most of them are significantly bigger than Earth and orbiting so close to their stars that they complete one revolution every several days. And there are some very strange worlds. Some have star-facing sides with temperatures that can melt iron, and have entire hemispheres covered with oceans of liquid molten rock. Other exoplanets the size of Jupiter orbit not one but two stars. If you were standing on the surface of one of these planets, you'd be able to see a binary sunset. But Kepler's legacy is that it successfully found Earth-sized worlds orbiting at a safe distance from their host stars inside what's known as a habitable zone or Goldilocks zone. This is where the temperatures are warm enough for water to condense on their surfaces, but not so cold that it will just freeze up entirely. Although being in this zone doesn't guarantee the existence of life, the presence of water is significant and the foundation of life as we know it. One such exoplanet discovered by Kepler that has recently generated excitement among researchers is called K2-18b. In September 2019, two scientific teams independently announced that they found signs of liquid water in the planet's atmosphere. Situated 124 light-years away from Earth, K2-18b is about 8 times the mass of Earth and 3 times as big. It orbits a main sequence red dwarf star called K2-18. A red dwarf star is the smallest, coolest star and by far the most common type of star in the Milky Way. According to Kepler's data, astronomers estimate that 6% of red dwarf stars have an Earth-sized planet in the Goldilocks zone, at least in our neighborhood. To find water on the surface of one such planet is a landmark discovery in the search for potentially habitable alien worlds. K2-18b is also the first planet with water out of all of the exoplanets discovered by Kepler in the habitable zone of stars. Kepler first discovered the planet in 2015, and since then its composition has been studied using other telescopes, like the Spitzer and Hubble Space Telescope. Kepler mainly used what's known as the transit method for exoplanet hunting. It essentially means that if a planet passes in front of a star, the light from the star dims slightly, and that's how we can tell that there's a planet there. The level of dimming and how long it lasts gives us important information about the size and orbit of the planet. However, detecting the transit of an extrasolar planet is very challenging. For example, the diameter of Earth is only 1/109th of that of the Sun. So, for an outside observer of the solar system, the passage of Earth would dim the output of the Sun by only 0.008%. Kepler's cameras had to be sensitive enough to detect this minute change in the luminosity. Using the same method way back in 2014, Kepler first found a potentially habitable exoplanet. Kepler 186f ignited the imaginations of space nerds everywhere when NASA announced its discovery. Now a new study indicates the exoplanet, 500 light-years away, may also have seasons and a climate similar to our own. New research out of Georgia Tech University has analyzed the planet's spin and axial tilt and found that its tilt is stable like Earth's, which makes it likely that Kepler 186f also has regular seasons and a stable climate. Similar research on the massive Kepler database is going on in research universities all across the world. In fact, in recent years, previous Kepler findings that were rejected as potential Earth-sized exoplanets due to algorithmic error are getting rediscovered. These false positives are now slowly being reanalyzed in conjunction with data from other telescopes. One such planet is Kepler 1649c. In mid-2020, while combing through old Kepler data and matching it against new data from the Transiting Exoplanet Survey satellite,